Today's lesson is the graphs of derivatives, and we've sort of seen this other places before, whether it's in science or physics, and earlier when we talked about just the single derivative. But I want to go through the steps of it again and sort of bring concavity into all this, because concavity can be very helpful in tying this stuff all together. And like I said before, concavity is like the final piece of the puzzle, and it really helps bring all this stuff together. So I'm going to start with some kind of graph, and I'll call this graph y, because when we're doing graphs of derivatives, we really want to establish which function we're talking about and which direction we're going. And I'll review these points at the bottom as I go along. So, I'm just putting some points on here to use, and I'm just making up a function that will be helpful in this. And this particular function has a max and a min and another max there. And so something like that, try and make it pretty smooth here. And then something like that, up to this max, and then down like that. So you're given some function like this, and a couple of exact points just to work with. Now, the first thing to do when you're going to graphs of derivatives is to take any of these max mins we see here. So there's a max and a min. And the one thing we do know about the derivative when we're going to graphs of derivatives is at max and mins, the derivative will be 0. So when we're going to a graph of the derivative, we can just draw a dotted line straight down and say, okay, at that particular point, we know the derivative graph will be 0. This brings up another point. When you're first doing these, if you have difficulty with them at all, always get the graphs right on top of each other like this. So that'll really help to line things up so you can see when things are happening. Then here's a minimum. So there's another time I know that the derivative graph will be 0. And then here, one more time, there. Now, away on the right-hand side, just a note for the physics people. This would be like a displacement graph, and then this would be like a velocity graph. So those of you who have that physics experience have a little advantage here. And so I'm going to write down here my first point about making derivative graphs. 1, max mins become zeros. So that's your first sort of guiding move here. Now, the next part, I'm going to do a lot of talking before I draw the next part, because we could just use our derivative thinking and go, okay, well, right here in this green part here, I'm just going to highlight in green, that part there is on its way up, so the derivative must be positive. So we need positive values. Then in between, we need negative values. And here, the other part I've highlighted, that would be positive values. And that would be enough to get the shape of the graph. So we may have seen that in previous sections where that would be enough to go ahead and draw a pretty good shape of our derivative graph, which is all we really want here is a good shape. But we have another point available here, and I'm going to change colors here and go right about here, and I'm sort of estimating it because we don't know exactly where it is this new point called a point of inflection. And we really got to talk about what that point of inflection means as far as the derivative is concerned, or as far as the slope is concerned. As we go up in that green part here, the slope's getting less and less as it heads towards 0. And even after the maximum we see at the top there, it continues to get less, right up until that red point. That's the moment where it switches from going that the derivative is getting less and less to the derivative starts to get more and more. And that's a difficult concept. It's one of those aha concepts when you look at it for a long time and you're like, oh, what do you mean by that? Well, when this thing's concave down, it means that the slope is getting smaller all the time. Like it's going from large positive values to less positive values all the way to 0, then to more and more negative values until it gets to that red point. And when it gets to that red point, now it's reached as low and negative as it's going to get. That's the most negative slope you're going to get. And if you really look at that for a second, you can see it's very negative slope right in there. And I'm going to add just a little tangent slope in there so you can see what I'm talking about right in there. That's as big a negative slope as we're going to get, because after that it starts to level out again and head back towards 0. What a great phrase. Then it starts to level out and head back towards 0. So that point of inflection when we go to the derivative graph is actually the minimum. And if that doesn't click for you, I suggest rewinding the video and watching all that again, because that is a huge moment in the understanding of how this all works. That's the moment where we get as much negative slope as we're going to get. And so on my graph down here, I'm getting as much negative slope as I'm going to get. And then it's easy to fill in the gaps here. It looks something like this and something like that. And it sort of looks like before that it was more and more positive the slope was going through here. Well, let's do that whole thing again on this next loop, okay? Well, we'll go through the whole thing again. We could use the fact that the green part is positive slope to say that, okay, then we'd get positive values of the derivative, and then over here, when it stops being green, we'd get negative values of the derivative, and we could just carry on like that. But we've got this extra point we can use, and I'm going to put it on red, and I'm just estimating because we can't exactly figure it out, but somewhere about there, we get this point of inflection where it starts going from getting more and more slope. See, from the first red point, the slope started coming back up again. It kept coming up towards 0, and then in the first part of the green graph, it started becoming more and more positive. But then at the red point, it stops getting more and more positive, and I'm going to draw a little tiny tangent in there to say, okay, right there, that's as much positive slope as we're going to get, and then it starts going back towards 0 again. What a great phrase. Starts coming back towards 0 again. So that point of inflection indicates where our max min is going to be. I don't know exactly how high to go here because we're only getting shape here, but I know it gets to a maximum at that value there. So then I know it comes up like that and down like that, and then more and more negative slope as I go along on that last section here. So it just continues on like that. Okay, so there's a lot of talking there, and so I want to break that down into points. What we decided is when it's increasing becomes positive derivative. And that's not new. We saw that before. But it is important to highlight that here. And decreasing becomes negative derivative. So where the y graph was increasing in that green part here, you see we get all positive values here. And then again, in the green part over here, it was all positive values. And I'm going to highlight those in green down here. There and there. See? Increasing in the y means positive in the y prime. And again, that was in another lesson way back when. But now we've got a fourth point, which is so good. I'm going to put it over here. Fourth point, concave down means y prime decreasing. And then 5 concave up means y prime will be increasing. And then that all brings us to point of inflection becomes max min. Good stuff there. Really good stuff there. And again, it's sort of an aha concept, and that if that all slipped by, if it was too much information too fast, then watch that part of the video again. I'm going to do the whole thing again, though. So yeah, if you're sort of like, I sort of get that, then let's do the whole thing again. Just a little faster this time, okay? So I've drawn some max mins on here, and so max mins becomes zeros. And you might be like, well, I don't know if that's exactly where the max min was, so I don't know if exactly where the 0 is. And you're right. Exact values, no. I'm just using these as guideposts to say, okay, it's about here that we would see these max mins. Now, where this y prime function, and I'm working on y double prime here, and for you physics people, I'm working on acceleration here, where this y prime is decreasing, then we get negative values. So I need to be down in here somewhere. and then between the minimum and the maximum, I'd be some positive values up here and then some negative values out there. And I'm not going to leave those on there. It's just I'm sort of thinking that's what we're going to get, sort of an upside down parabola looking thing here. But I'm going to try and use those points of inflection to really think about what's happening here is where it goes from concave up to concave down. The way I've drawn my graph, it really looks like the concave up. I'm going to put it on here is this point of inflection right there where it goes from concave up to concave down. That's where I get my minimum or maximum. Now, is it going to be a minimum or maximum? Well, we're going from concave down to concave up, which means we're going from a decreasing derivative, an increasing derivative to a decreasing derivative. So that means we're going to be a max. So I don't know exactly where, somewhere about there. I've drawn that in red to really highlight that point there. So we went from negative slopes up to positive slopes and then back to negative slopes in there. Okay? And then it continues on more and more negative slopes. And if that isn't enough, I can really put a real final exclamation mark on it. Just imagine if we had the degree of this y looks like sort of a degree 4, and then when we take the derivative, we sort of get a degree 3, and then we take the derivative again, we sort of get a degree 2. So that sort of matches up. When we see all that, we're like, oh, I feel pretty good about that whole situation. By the way, by the end, you got so many arrows and dots and lines in here that it gets confusing to look back on the whole thing. So you really have to watch the video as it develops to be able to get all those things. So that's going the one way. That's finding graphs of derivatives. Now this, a new word today. Big word in calculus. I'm going to call it making antiderivatives. You can say just going backwards if you want. That's totally fine if you want to just say going backwards. And so when I do that, now me personally, what I like to do is I like to start with my y double prime. When I'm just learning about this, I start with my double derivative graph down here. And then when I'm going backwards, I actually make the graphs going this way. And that's a little easier thinking than trying to go the other way. So if there's like a textbook question that asks you to make from the double derivative graph, they want the single derivative and the original graph. That's fine, but put the double derivative graph down at the bottom and then work upwards. That sort of helps you there. So I'm going to just make a little graph here. I'm going to make one that's like, goes like this, and maybe has something like that. And when that happens, all the thinking just gets reversed. So instead of a max min becoming a zero becomes a max min. But then you got to do some thinking about, is it a max or is it a min? So take a look at this y double prime graph, and it's got a 0 right here. And I'm going to switch over and say, okay, these are the points I'm thinking about here, that right there. And we're going from a double derivative that had positive values to a double derivative that had negative values as I switch over at that point. That means it's going from sort of an increasing to a decreasing when I go upwards into the y prime graph. Wow, that's weird, right? Really weird, all right? But positive values here, and I'm just going to highlight that, positive values here mean as I go backwards, I must be talking about increasing, because this is a derivative we're talking about. It's a double derivative. It's a derivative of the single derivative. So what I get here is some kind of max here. And I don't know exactly where the max is going to be. I'm going to put it right on a dot just to use it as reference, but I don't really know where that is. But since the double derivative is positive, this thing must have been increasing to get that positive derivative. Then the double derivative goes negative for a while, so I've got to go negative for a while down to a minimum at this other 0. So let me just line those up for you there. So in between there, I'm getting negative values for the derivative, so that must be decreasing. And then back to increasing after that. And I've made random zeros here, and you might say, well, you just put those zeros where you want. Yeah, I know, I'm just using them as reference points to get a shape here. I won't know the exact values. I won't know the exact values when I'm doing the antiderivative. Antiderivative means backwards. Okay, one more time. So if that's like, whoa, yeah, it is well. Let me just write down some notes. So 1, zeros become max mins. And then 2, positive values become increasing. 3 negative values become decreasing. Now, higher level, a little harder to do. These are hard to nail, is that our max mins become points of inflection. Again, that's the opposite thinking from when we were doing the derivative graphs. And then, so let's do it one more time here. So what was the first thing? Instead of max mins becoming zeros, zeros become max mins. But let's look here. Before this 0, which is going to be a max min, I've got negative values for the derivative, which means over here it must have been decreasing into that value there. Then my next 0, which becomes a max, and that's because I'm going from positive values to negative values of the derivative. Positive values means increasing, and then after that it'll be negative values, and my last one is here, something like that, Okay, let's match those up just a little bit. I'm going to put some green stuff on here. So these were y prime positive. Oh, sorry. That's not what I wanted. In this green part, negative y primes means decreasing in here, so that matches up with this part here. And then in here we had positive. Oops. In here we had positive values of the derivative. Those are all positive values, and so that meant increasing up here. And then over here we had negative values for the derivative, and that meant decreasing. And then back in the last section, these were positive values, positive values for the derivative. Last section there. Can't get my highlighter to work. There it goes. Positive values for the derivative meant increasing in that last part there. I will not pretend these are easy. There's no way they're easy. It really is going to take watching the video, then go and try a couple questions of the homework, then come back, watch the video again, watch a section of the video. But it is sort of an aha concept where all of a sudden you go, oh, I've got it, and then you've got it. So it's not the worst thing ever. It just takes a little time. And for you physics people, I went from acceleration to velocity up to displacement. The reason I know it's displacement is because it has positive and negative values, which you wouldn't get for distance. Okay, give those a try. And I acknowledge right now they're difficult. So the first time you go through it and you're like, I don't get it. Don't freak out. Just check it out again and try it again. Okay, have a great day.